Good morning, everybody. Hopefully you guys are doing good. Had a lovely planning block with Mrs. Wood this morning. If you don't mind putting a green check in so I know you're with me. And then we'll get started here in a second. I kind of did a few sections. I don't know if a few sections. The last unit, lesson 4, is just sort of applications, just a couple word problems in the learning guide. So I kind of did a couple examples last day, but I'm not going to start the next unit yet. I would like to make sure you guys are kind of okay with this unit first. So if you have questions, I'd love it if you threw them in the chat. Looks like we have a full crowd today. I don't remember the last time I saw all of you guys in here. How many do we have? Look at that. Not bad. Missing one or two. Yeah, so basically today I just wanted to tie up some loose ends and go over any questions you guys had on this exponent stuff, and then just kind of let you guys have some time to work. I don't want to start Unit 4 yet. Unit 4 is a little bit different than the stuff we've been doing. It's maybe stuff you're more familiar with, but it's kind of not the same. So the radicals and the exponents are all kind of the same, but now we want to get that kind of out of the way. I see Taylor's thrown some questions in chat. Does anybody have any questions from the learning guide? Or I said there was those extra practice sheets that I have here, lesson 3 extra practice and lesson 2 extra practice. If you had anything you wanted to go over there, I'd be happy to go through that. Well, people are writing in a few questions. I just want to mention a few things about kind of where we are in the course and where we're going. There's 8 units. We've done 3, and we have 1 unit left before the midpoint of the semester. So basically, we'll have 3.5 units out of the way by the time we write the midterm. Now, I was having a chat with Mrs. Wood and one of our administrators here, Mr. Gray, and I was thinking I'll probably just have the midterm. I think we said the 9th was the midterm date. The midterm, it'll just be a paper copy, so we won't even have to deal with computers or anything like that. There'll be, I haven't made it yet. There'll be multiple choice for the beginning, and then a few written questions. And it'll be on the first 3 units. So the first one we did was surface area and volume of shapes. Then we went on to unit number 1, which was radicals. And then we did unit 3, which was exponents. And then unit 4 is polynomials and things like that. So I want to spend a little bit of time on unit 4 because it's a bit of a tricky one. And that will kind of be the midterm. So as far as we get into unit 4, I'll try to include a few unit 4 questions on the midterm, but the majority of the midterm will be units 1, 2, and 3 with a few unit 4 questions sprinkled in there depending on how far we get into that unit. So a few questions that have been posted in here, some stuff to go over. Perfect, I'd be happy to go through those things for you. And then how much will it impact our mark? I actually don't remember. It's on the very top of the course. I had a course outline. Oh, I think I went through it on day 1. I might have to double check that. Exactly how much it is worth. I want to say I forget. I think it's 15% of your grade or something like that. Yeah, I don't remember. Maybe somebody who does remember could chime in on that. There's a few questions here on the learning guide, so I'm going to go through those. And then anything from the extra practice, I'd be happy to go through as well. I noticed some of you are still finishing up the Unit 1 stuff, which is, I guess it is what it is, but it'd be really great to get that out of the way before you have this Unit 3 test, because you don't want to be doing 2 units at the same time. So kind of been pushing us to get moving here, and some of you getting the message and some aren't. So let's try to stay current. In terms of this unit, it'll be done today, so if you can get the learning guide in today or tomorrow, that'd be amazing. Test written by the end of the week would be good, because Unit 4 will be, we'll start Unit 4 tomorrow, and then we won't see each other again until the following Monday, because Mrs. Ward is going to take all of Thursday, just like I took all of yesterday. So she's going to take all of Thursday's class. So tomorrow will be our last day together for this week, and then we'll see you again on Monday in the morning. So page 4, number 4, page 9, number 8, page 5, page 5. Oh, and rational exponents 5b, 7b, 9a. All right. First one, page 4, number 4. Let's start there. This may be a bit of flipping back and forth for me. I apologize for that, but I just want to make sure you guys get to see everything you have questions about. This page 4, number 4. Use exponent division to explain why a 0 power is equivalent to 1. Let's pick something like 2 squared over 2 squared. If I have the same thing on the top and the bottom, these things just simply will cancel out. Or I could write them as 2 squared is 4 over 4. So 4 divided by 4 is 1. So that's if I actually calculated it. Now it really doesn't matter what the bases or the exponents are, as long as they're the same. So I could do the same thing and think of it this way: 2 to the power of 2, 2 to the power of 2. I have the same base. I can subtract my exponent. So 2 minus 2 is 2 to the power of 0. And we know from what we just did, 2 to the power of 0 is going to give us 1. So that was number 4. Hopefully that makes sense. I've done that a few times. Type of question. The next ones, we had some on page 5. Number 1, 2. Page 9. Page 5. Number 1, number 2. I'm seeing a lot of page 5, number 1, number 2. I did those ones. Raising a power to an exponent. I forget which one's here now. Page 5, number 1, negative exponent. Number 2, negative exponent 7d. This is all quite confusing. Let's pick a couple of these to do. Maybe we'll pick D here and E. See how we do with those guys. So I have this exponent outside, and I know the exponent law I'm dealing with here is a to the m raised to the n is a to the m times n. So this is the basic exponent law that all these questions are dealing with. So if I have an exponent outside the bracket, everything inside gets that exponent. So I get 3 squared x to the 2 times 2. And this 3 squared is just really 3 times 1. Or sorry, the exponent is 2 times 1, but I don't write in the 1 because I know it's there, I just kind of ignore it. So I get 3 squared and then x to the 4, and then 3 squared I could write as 9. I assume they want the answer here. 9x 4, or 3 squared x 4. Same thing here. I get negative 2 squared y 3 times 2. Two squared is 4, y is 6. So 4y 6. We can do the same thing with these guys. Multiply the 3 by all these. So x to the 3 times 3, y to the 2 times 3, z to the 4 times 3. X to the 9, y to the 6, z to the 12. I always forget to raise the number of the exponent as well, the constant. Yeah, you can't forget that constant out front. Even, so sometimes the constants will have exponents. There's a 1 there, right? We have this little 1, it just kind of sits there, but we don't write it in. So try not to forget it. It is there. If you recognize your mistake, but if that helps, then there you go. So I think I've done actually most of page 5. Yes. What else? Page 5, got that. Rational exponents, number 5b, 7, 9a. Page 6. Page 6, 4b. I think the next one there. So here's 4b on page 6. What's the missing power? So this kind of referring back to our exponent laws. If we are multiplying with the same base, we add our exponents. So what this is really saying is m to the 3 plus negative 4 plus something equals m to the negative 2. Now the bases are all the same, so all we need to do is just look at what the top was. So I had 3 plus negative 4 plus, we'll call it x, equals negative 2. So all I've done is just made a math equation out of the exponents, because I know I'm going to add all of those together. Now I can solve for x, or I can just solve by inspection. 3 plus negative 4 is negative 1. So what is x going to be to give me negative 2? Both sides of this must be the same thing. So I guess I can solve it mathematically. There's nothing wrong with that. 3 plus negative 4 is negative 1 plus x equals negative 2. And then I'm going to add 1 to both sides. I'm going to get x is negative 1. So I know the missing exponent is negative 1. And my bases must be the same. So I get m to the negative 1. And does that work? Why is that? Yes, that works. There we go. It's an m to the negative 1. Pretty good there. Jumping back into chat here. Page 5 I got to. Page 6, page 8, page 9. Page 7, 13D is the next one I see. Page 7, 13D. Whew. It's a scary looking one. All right, let's just tackle it a step at a time. First thing I'm going to do is deal with my exponent of negative 2, because I want to end up with a positive exponent there. I hate dealing with negative exponents. So I'm going to flip everything in there. 3x to negative 3, y to the 3, over 4x to negative 2, y to the negative 1. All to a positive exponent now. All 3. So all I've done is flipped everything in the first bracket, taken the reciprocal to make my exponent go from a negative to a positive. There's a couple ways I can approach this now. I can either just do subtraction of my exponents inside the brackets, or I could flip my negative exponents to the top and bottom if they're negative to make them positive. Maybe let's do that, or not. Negative 3 minus negative 2. Yeah, let's do it this way. Anything that's negative in here, I'm going to flip to the opposite side. So I have this negative 3 on the top. My 3 and 4 will stay the same. I'm going to move it to the bottom. Then this y to the positive 3 is still on the top. So I'm going to leave it there. Down here I had x to the negative 2. I'm going to bring that to the top and make it positive. And then I have y to the negative 1 down here. I'm going to bring it to the top and make it positive. Do the same thing in the second bracket. I still have 2 over 6, which can be simplified, which I'll get to in a second. x to the negative 3 here from the bottom goes to the top, becomes positive. Sorry. I have x to the positive 4, which was on the top, and I bring it to the bottom. I have y to the 2, and then y to the 1. And we're off to the races. All right. Maybe I'll combine my y's together. I have y's on the top. So I get 3x squared. When I multiply, I add. So y to the 4, x to the 3, all squared. And 2 over 6, x to the 3, y to the 3, x to the 4. So all I've done there is combine my y's together. Taylor is asking, why did I bring my x's up to the y's up to the top? Well, I had up above here, one of my y's was positive, so I left it there. And then my y on the bottom was negative, so in order to bring it to the top, I had to make it positive. So this y to the 3 here, this doesn't move. It just stays there. And then I have this y, the positive one, which came from the bottom because it was negative. Now it's positive on the top. Same deal over here. Y to the 2 didn't move. It just stays there. And then in order to make this positive, I brought it to the top. It's a lot of stuff going on there. All right, I'm going to cancel out my exponents here. I have 3 x's on the bottom right here, and I have 2 on the top. So I'm going to lose all of these, and I'm going to be left with 1. 3 and 4 can't simplify. The y to the 4 can't simplify. 2 and 6, 2 goes into 2 one time, 2 goes into 6 3 times. I have 3 x's on the top and 4 on the bottom. Just leaves me with 1. So I'm just going to rewrite everything. 3 over 4. I have y to the 4 x. This is all squared. And I have y to the 3 on the top times 3x on the bottom. Okay, I'm going to deal with my exponents outside of the brackets here now. So everything inside the brackets gets each of these exponents, and I'm going to multiply them times whatever's there. So this is just 3 times 1 is 3, 4 times 2 is 8. It's just what I'm going to do. So I get 3 squared, get y to the 8 over 4 squared, x to the 2. And then I get y to the 9, 3 and 3 is 9, 3 cubed, x to the 3. I'm just going to keep going down my page here. I might run out of room and write over this other text, but that'll be okay. Now I'm just multiplying. So I'm going to just write everything. I'm just going to rewrite everything. I have 3 squared, y to the 8, y to the 9, 4 squared, x squared, 3 squared, x cubed. So I've just written everything over one line. I'm multiplying up above here. I can do that, just everything over one fraction. Now I can look, is there anything I can simplify before I continue on? Well, I have this 3 squared on the top. I have 3 cubed on the bottom. I missed the 3 there. Wrote it as a 2. 3 cubed on the bottom. So I can get rid of these 2 on the top, and I'll left with just a 1 here, just a 3 on the bottom. I have 2 x's, which I can add to these 3, and I have these y's, which I can add together. And then I have a 4 and a 3. So I'm going to do a few things here. I'm going to add my tops together. So 8 and 9. gives me 17. So y to the 17. On the bottom, I have 4 squared, and I have multiply that by 3, and then x to the 5. Now, I don't know if the answer has the 4 and the 3 combined together or not, but I'll just assume it does. 16 times 3 is 48. So y to the 17, 48, x to the 5. Whew. This gets back to the idea of there being more than one way to do these problems. There's no way that's any more correct than the other. As long as you're adhering to a basic order of operations, BEDMAS, you're going to be fine. So if you want to leave negative exponents in there, that's okay. As long as the answer doesn't have a negative exponent, you can multiply the exponent outside the brackets by everything inside, even if there's negatives in there. You could have subtracted all of your exponents for the division at the very beginning and just had everything on the top, even though they were negative. I chose to leave everything in fractions and just go through it that way. So if you're sitting here and you're thinking, I wouldn't have done that step next, that's fine. There's more than one way to do these. So if you've kind of ended up with the same answer and got there a different way, there's nothing wrong with that. Even on a test, if I asked you to show your work and you did it a completely different way than I did, there's no one way that's more correct than another. And there's probably about 1,000 different ways to do that one question. So don't get caught up on the how, just be confident with your exponent laws and what you're doing, when you're doing it, and why you're doing it, and you should end up at the right spot. I'm going to jump back into chat here. So that was page 7? Yes. So I'm on anything on page 8. Page 8, 1 and 2, I see. Anything else from page 8? Some page 9 stuff. All right, so page 8, Abby, you had a question. Page 8, 1 and 2, I assume that's what you asked up above. So let's look at that. Page 8, 1 and 2. Rational exponents. Is the example of the 3 is called the... these are probably words that we don't see a lot. I would go 3 is called the root. I don't know what the answer guide said. I would call it the root, though. And then the 7, we could call it the radicand, but that's probably not what is written there. Index in the radicand? Sure. This is just kind of a finicky vocab thing. I wouldn't lose sleep over it. And yeah, index and radicand. Not things you'll hear. I wouldn't think that they'll ever come up or be important, but I'm glad you asked, Abby. Just kind of get that out of the way. Number 2, explain why the cube root of 6 is equal to 6 to the power of 1 over 3. This is one of these explain why things. Math is kind of funny in that there's not a lot of explanation why. If you can prove it using numbers or even your calculator, that's kind of acceptable. That's kind of the basis of math. So again, you're not going to end up with a question like this on a test or a final exam where they're like, explain why the cube root of 6 is equal to 6 to the 1/3. I wouldn't lose any sleep over this either. I mean, we did some examples at the beginning of last day's class, or I guess in the middle, where we had something like, what did we use? I think we used 4 to the 1/2, and then we calculated that, and then we found it was 2, and then we did the square root of 4, which was still 2. I don't know. If you can sort of justify it using an example, I'm sure that'd be acceptable. Again, it's one of these kind of things that we don't want to worry about too much. This is a number multiplied by itself 3 times. When it's the exponent on the bottom or the base, same deal again. You can look at it in the video, like Avery's saying. Again, I wouldn't worry about it that much. It's not super important stuff. What else do we have? Page 8, 1 and 2, index. Avery was on that for me. Thank you, Avery. 13C. I did 13C last day, Belle. Hopefully you can check the video from last day as well. Page 9, 8C. Anything else from page 9? Page 9, 8C. Looks like a couple page 9, 8Cs. Uh, 8C, right in exponential form. So we have this radical sign, and we want to get rid of it. We want to turn it into an exponent. So let's see what we can do. Not very nice of me to not leave any room here. So I'm going to take everything I have here, x to the 5th, 16y cubed, and I'm going to raise it to the power of 1 over 4. Now the reason I can do that is because I don't have any exponent out back here, and everything in front is what's going to be on the bottom of my fractional exponent. Now at this point I'm going to multiply everything inside my brackets, all of my exponents inside my brackets, by this power of 1 over 4. So I'm going to get, maybe I'll show this in 2 steps, x to the 5 over 1 times 1 over 4 on the top, 16 to the power of 1 over 4, and y to the power of 3 over 1 times 1 over 4. So on the top I get x to the power of 5 over 4, multiplying my fractions through. 16 to the 1 over 4 is just going to be 2. It's the 4th root of 16, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So that simplifies. And then y to the 3 over 4. I'm imagining they probably left it like that in the solution guide. Hopefully they didn't rationalize it or anything like that fancy. That would be good if you get it that far. Page 9, 999. 98C, 13C, got negative exponents, 9D, and got page 7, 9, 8C. They didn't simplify it. Perfect. Is there anything that I missed? There was a lot of questions there, and anything that I didn't go over that you guys wanted? Number 8D on page 9. Yeah, for sure. This guy down here. This is the rule I talked about with the fancy little rhyme. Flowers of power, roots the root. So everything on the top is just 1, so I can just leave it like that. On the bottom, I'm going to take this m and flowers the power. So 7 goes on top, and the 4 is the root out front. It's 7 over 4. And I would imagine they're going to be happy with that. You could move it to the top by making it negative if you wanted, but I don't think that they probably would do that. So is 8D. Page 6, negative exponents, 2C, and I can do B as well. All right. So here's B. I have this 3x, that's my base. And my exponent is the 3, so I know that that's going to go on the top, and whatever's out front is going to go on the bottom of my exponent here. So I'm going to rewrite it as 3 over 5. And I'm going to put everything in the bracket, 3 over 5. So that's converting from a radical form into our exponential form. Go back and forth on all those. Page 6, negative exponents 2c. Let's rewrite powers of fractions with a positive exponent. All right, so we want a positive exponent. We're looking at this guy here. In order to get this positive, I'm going to take the reciprocal of whatever's there. So this is x over y over, or x times y over 1. If I want my power to be positive, I'm going to take the reciprocal of everything inside the bracket. So I'm going to get 1 over xy to the power of 4. And it's possible that they went x to the 4, y to the 4, simplifying everything inside the bracket with a 4. Let's look at D as well, mine as well while we're here. I have B over 1 essentially. If I want this to be positive, I'm going to go and leave my negative sign on the top to the positive 2. I always like leaving the negatives on the top of my fractions. I've probably said that last day a few times. It's just kind of how I like to do math. I like the negatives up top. You could have written it as 1 over b, the negative out front, or you could have written it as 1 over negative b there. That's all fine. They're all the same thing. That negative can go wherever you want to put it, but just be consistent. Does anybody have any other questions about the learning guides or the other questions there, the extra practice stuff that's there? If nobody has any questions, I might just do a couple of the tricky ones out of the extra practice just so you can see a few more. Like I said at the beginning of the block here, I don't want to start Unit 4 yet, so I'm not going to. And then looks like there's one more question here Abby's asking. So we look at page 9, 7A or B. Page 9, 7A or B. Okay. All right, so just so I understand your question correctly, I got the right answer for them, but because of the order of how I did it, I got it with a radicand simplified, but they wanted it with the exponents. So if I'm understanding what you've written there correctly, it's just they didn't calculate the actual number. Let's see what, I'll just do it and maybe we'll see where we end up. So I have a negative exponent. I want to make it positive. I'm going to take the reciprocal of everything inside here. So I'm going to have 1 over negative 4 to the power of 3. And this is all to the power of 1 over 4 now. The 1 to the power of 1 over 4 is just going to give me 1 over 4. And on the bottom, I'm going to have 1 over negative 4 to the power of 3 over 4. Now, if I'm understanding your question correctly, they left it there. Sorry, negative sign. But you simplified the negative 4 to the 3 first. Oh, you actually did the calculation like 4 times 4 times 4. I see what you're saying now. And then they just did it that way. Yeah, maybe as a general rule, we could just go, if you have a number raised to an exponent, maybe don't actually calculate what that number is until the very end. Of course, on a test when you have a multiple choice answer or something along those lines, you can look at how the answers are formulated and say, oh, all of the constants have exponents. They haven't actually calculated what they are. And sometimes in questions like these, when you work through them, you'll find other 4s to deal with, and then you can deal with the exponents on the other 4s and maybe add or subtract and things like that. So that's probably where they were coming from there. Let's do this one as well while we're here. 1 over 7, so I'm going to get 1 over 5 to the power of 3, the power of 1 over 7. Now positive, because I took the reciprocal, everything inside gets the exponent. And then 1 to the power of 1 over 7 is just going to be 1. So we don't really need to worry about giving our 1 any exponent because it's not going to change anything. It's just going to remain 1. So 5 to the 3 over 7. Just thinking about 5 to the 3 over 7, that's going to be a really awkward decimal because you're taking the 7th root of 5 and then you're cubing it. It's just going to be a bit of a mess. So just leave them as exponents. There's nothing wrong with that. Alex, page 6-9b was another question there. 7-6-9b. Rewrite these with positive exponents only. Okay, this is a good question. These can get tricky when everything kind of flips. So anything that has a negative exponent, you can either move it to the top to make it positive, or if it's on the top and it's negative, you move it to the bottom. We're taking the reciprocal. So everything's moving except the 3. And you'll notice that the 3 doesn't have an exponent, so the exponent on the 3 is just going to be a 1. And it's a positive 1, so I don't actually flip it. I just leave it there. So everything's going to move, except that 3 is going to stay there. So this y to the negative 2, I'm going to put it on the bottom, and my exponent's going to become positive 2, because I took the reciprocal of it. I flipped it. And then the z to the negative 5, I'm going to put it on the bottom, and my exponent becomes positive. And then the x to the 3, on the bottom here goes to the top, and my exponent becomes positive. So the 3 stays because it had a positive 1 exponent. It wasn't negative. Everything else moves. This is an x, a y, and a z. I can't simplify those. They don't have the same bases, so there's nothing I can really do to further that. I don't have any negative exponents left, so I'm kind of happy with where I've ended up there. And that's all you can do with that. There's only kind of one step there. Good. Glad it makes sense for you, Alex. I'm going to give the one last call for any questions there, and then maybe I'll just load a couple questions from the learning guide up. 6B on the same page, sure. Rewrite these multiplication with positive exponents. All right, so 7, and then this is 2 to the negative 5. So in order to make it positive, I'm going to multiply it by 1 over 2 to the 5th power. And then both things inside the bracket get the exponent of 5. So I have 7 times 1 to the 5, which is just 1, 2 to the 5. Kind of looks like 25. 2 to the power of 5. And then I'll just write them as one fraction. So 7 times 1 on the top is 7. 2 to the 5 times 1 on the bottom is 2 to the 5. And I have a feeling that they didn't actually calculate the number again. They probably just left it like that. So hopefully that helps a little bit for 6B there. And I think that's it. Maybe. See, Alex. If there's a positive on the bottom, do you move it to the top? I'm not sure I'm understanding your question, Alex. If there's a positive on the bottom, like if I had something like this over here, if I had like 2x to the negative 3y squared x to the 3, and then, oh, you put an example. I'll just finish this one off. So if this says get rid of my negative exponents, I'm going to move this one to the bottom. This one's going to stay, and this one's also going to stay because they're both positive still. So the 2 had an exponent of positive 1, so I leave it. The y was positive, so it stays there, y2. And then I move the x to the 3 down, and then this x to the 3 stays there. Yeah, so then I could just simplify that as 2y squared x. Add my exponents, 6. 3 plus 3. So yeah, if it's positive on the top or the bottom, you don't move it. The only reason we'd move something is because the exponent was negative. So we'd want to get it to a positive exponent, so we'd take the reciprocal. Yeah, so if anything's positive, that's just a good general rule. If anything's positive, we're not going to move it. It's happy where it is. It's a positive exponent. We're okay with dealing with positive exponents. We just want to get rid of the negative ones. So that's kind of that. Yeah. I just want to take a peek into the course, and actually I might have access to it from here. See if I can do it. Lesson 3, Unit 3, Lesson 2 assignment. Let's look at this. I'm just going to bring up the extra practice, and maybe I'll do a couple of the tricky questions out of it. And then we'll set you free. Let's just take a second to load. Gotta flip my screen back around. Joys of using a tablet. For the very last question, do they just want us to estimate the answer or leave it in radical form? Not sure what question you're referring to, Abby. The very last question that I did, or the very last question in the learning guide? Like number 3 here, I'm thinking you're talking. This type of question, they've given you numbers with decimals in them. And if you see a question with decimals like this, the 0.93 and the 1.25, and then even in the actual formula that they're using, yeah, they're definitely looking for an answer with a decimal. You want to calculate it. The question's asking height and stride length. It's talking about, I guess, the speed at which these people travel. So it's wanting an answer. Because if I asked you how fast can you run? And you said, 2.73 to the power of 19 over 7. Like, oh, that's great. I have no idea what that means, though. This is kind of one of those questions where it makes a lot of sense to actually calculate it as a decimal. And again, you can use your judgment. If it's a multiple choice type question, it'll say 1 decimal place or something like that. And you just kind of use your judgment, I guess. It's usually clear. If a question gives you a bunch of decimals, then it's probably looking for an answer with a decimal. If your question has just whole numbers in it, with the exception of maybe fractional exponents, then it's probably looking for an answer with just whole numbers in it. So this was lesson 2, extra practice. I said have a look at it. Maybe I'll do a couple of the tricky questions here. I don't know how many of you actually had a chance to look at this, but evaluate the following. It's pretty straightforward. Solve for x. Maybe I'll do a couple of these guys here. We do have about 10 or so minutes, so geez, I don't know. I like j. That's easy. That's 1. Anything to the exponent 0, it's going to give us 1. That was a bit of a trick question. Maybe we'll look at n here. This looks like a bit of a messy one. So what I'm going to do first thing is I notice I have an exponent of -2. So I want to get rid of my exponent of -2. So I'm going to flip everything inside the brackets. So I'm going to bring everything that was on the bottom to the top, regardless if it was positive or negative. Remember, I'm only doing one step at a time. So all of this is going to go on the top. I have 3x to the -4 y cubed. And then on the bottom, I'm now going to have 5x -2 y to the -3. And all this is going to be to the power of +2 now. So even though I had negative exponents within that bracket, I'm going to reciprocate everything, or find the reciprocal of everything, flip everything, because the first step I was doing was getting this -2 to become a +2. So after I've done that, what I can do now is many things. I can simplify what's inside the brackets. If I wanted, I could take the exponent of 2 that's outside the big brackets and multiply all the exponents within the brackets by the 2. I could do that. I kind of like to simplify everything inside the brackets first and then go from there. So that's what I'm going to do. I'm going to go, this x was negative on the top, so I'm going to move it to the bottom to make it positive. And this is negative on the bottom. I'm going to move it to the top. This y to the 3 was positive, so it's going to stay there. That was kind of a question that was asked a little bit earlier. And then this y to the -3 on the bottom is negative, so if I move it to the top, it becomes positive. I'm going to combine these together to get 6. And then I have my 2. So I have x's on the top and the bottom. I'm going to simplify those. I have 2 here. Those are going to cancel with 2 of those 4. I'm going to be left with 2. So I have 3. My x's are all gone here. I have y to the 6. -5x squared. Now everything gets the 2. I get 3 to the power of 2, y to the 6 times 2 is 12, -5 to the 2, and x to the 2 times 2 is 4. And I have a feeling they probably just left it like that. I don't have x's and y's on the top and bottom. Kind of just happy where that ended. So if you are a bit uncertain and you want a bit more practice, there was those two extra practice sheets that I included in the course, and they'll have the solutions as videos in the course, so you can watch those if you're confused on any of these questions or you want to see a few more done. It's one of these things, you can watch me do the questions a lot, and it's not going to make it any easier for you. It's kind of something that you just need to do in practice and kind of become comfortable with. If you're getting answers wrong constantly, then ask for help, but basically it's just a matter of you putting in a little bit of time here. So I'm gonna end her here, and I would like it very much if you guys could finish off Unit 1 stuff, first of all, and then this Unit 3 that we've been working on, if you can get the learning guide in today or tomorrow, that'd be great, and maybe write the test sometime on the weekend or Friday or something like that. I think there's 3 or 4 quizzes for this unit in the course. So take this time right now to maybe try one of those quizzes if you haven't, or do some extra practice or something like that. So I don't have anything else. Hopefully I'm going to be going to the art gallery today. So if you're coming with us, that'd be really great to see you guys out. And yeah, the quizzes you should always do. They do count for marks. I mean, I think I said at the beginning each quiz was something like 0.3% of your grade. So it's not a lot. If you got 0, it wouldn't affect your grade at all on a quiz. But just do them all. They are there to help. And then the questions on the quizzes come up on the test. Remember, it's the same test bank for the quizzes and the test. So I'm going to leave you there. We're going to start Unit 4 tomorrow. And then you guys can have your weekend to do the test on this stuff. I won't see you on Thursday. And that's kind of everything. So have a good one, and we'll talk to you guys soon. Bye-bye.